Well, hello Internet, and welcome to a pretty crazy video. In this one video, I am going to teach you the core of what you need to know to get vast majority of everything you could ever want to get done with Numpy, Pandas, and Plotly, all in one video. And I have a lot to do, so let's get into it. So you might say to yourself, well, that's promising a lot. I'm going to show you here how to create arrays, matrices, randomized arrays, how to reshape arrays. It's extremely important to be able to organize your data the way you want, how to filter, how to use different statistics. I'm going to get into pandas. I'm going to show you how to read from CSV files, Excel files, even off of tables on HTML sites. I'm going to show you how to organize that, clean up your data in numerous different ways. I'm going to show you how to replace column names, remove different odd characters. I'm going to cover how to select individual columns in multiple different ways. I'm going to show you how to work with multiple different columns, grab rows of data, add columns, delete rows, manipulate your data in countless different ways. All of these files are available in the description. And everything is heavily commented. We're going to get into Plotly. We're going to make really sophisticated types of graphs. We're going to add in different styling. We're going to add in the ability to zoom in on data with sliders. I'm going to also show you how to add buttons to your graphs to automatically change your data just by clicking a button. We're going to get into candlesticks. We're going to do sophisticated different shading, drawing different shapes on your plots, adding annotations. I'm going to cover open, high, low, close charts, multiple different plots at the same different time. Also, we're going to have sliders on all of this data. This information is extremely useful, especially if you're interested in data science and, of course, in finance in general. And I'm going to cover everything right now. All right, so I have a lot to cover, so I went and automatically put in here all the different libraries you're going to need. And also another tip is this guy right here. Occasionally, whenever you are using Anaconda, you'll come across situations where you have variables that you previously had in your code and you want all the variable values to be reset. This is what you use right there. Just a tip that I have told people about in comments, so I bring it up. Okay, so we have NumPy, which you're going to see tons of examples of how to use NumPy. Just quite simply allows you to use large multi-dimensional arrays amongst numerous other capabilities, math operators, and so forth, as you will see. Pandas extends Python, more data manipulation and analysis. Data reader is going to be used to read information from online and also on your file. So it just provides data in a data frame format, which we'll get more into data frames. Matplotlib, this is going to cover plotting, and this is just going to keep little silly warnings from popping up. You can leave it on or take it off. It's up to you. Constants. Now, I tested everything here on Mac as well as Windows. Actually, I did everything on Windows before Mac, so I know everything works. And one thing you'll need to change is your path. And of course, I doubt you have a Derek Banis directory, so you're going to have to point at where your files are. And all of the files, as well as this file right here, is available in the description for free from GitHub. All right, first thing we want to do, we want to create a NumPy array. So what we're going to do is we're just going to create a list, and we're just going to throw some different values inside of there. It doesn't matter what they are. And to convert this into a NumPy array, we can just call this NumPy array 1, like that. All you need to do is say numpy.array and then pass your list inside of it. And then if you want to go and see what it looks like, there it is. All right, so now it is a NumPy array. Now you can create arrays in ranges of values as well as steps and so forth. And one thing you can do here, and I guess I didn't even mention it, basically NumPy is just quite simply an amazing scientific computing library. It is used by numerous other Python data science libraries. It contains many mathematical, array, string functions, and it is an extremely useful library. Along with all the basic math functions, you're also going to find functions for linear algebra, statistics, simulations, and so forth and so on. All right, so there, rundown of what exactly NumPy is. So let's say we want to create an array in a range quickly. And let's just start off something simple. Let's go numpy array, and you would just say numpy a range, like a range of values. And this is going to give you values from 0 to 4. And you can just go like this, and there you can see we generated those. Now let's say that you would like to step through the values, like you would like to show every other value. Like you would like to have 0 through 9, and you want to show only the even values. How could you do that? Well, let's go create another one here. And again, NP, that stands for numpy, a range like that. And we can go 0, let's say 0 through 10. Remember, it's not going to print the last value. And then we can say 2 like this, and numpy array 3. And you can see that's another way. And you could go and use mathematical operators and so forth inside of here for generating the different steps. Now, matrices are extremely useful, especially with data science. So we're going to spend a lot of time with those. Let's say I want to create a 4-row matrix with 3 columns, and I want every single value to have the value of 1. Well, let's go matrix is equal to, and numpy, and 1s, and what did I say I want? I want 4 rows. So you're going to put your rows in first, and then you want your columns, right like that. And then you can go, and you can see I created exactly that. 4 rows of 3 columns each. All right. Now what I want to do is I want to create a 4-row matrix with 3 columns, all having the value of 0. Well, guess what? You do almost exactly the same thing. So I'm just going to copy this, paste this inside of here, and let's just call this number 2 just to keep everything different. A lot of people use the same variables over and over again going down these sheets. I do not. Do whatever you would like, but I think it works much better to take the time and go and do different ones. All right. And you can see there we did that. We're also going to be able to generate random values. So inside of matrices. And this is extremely useful in data science. So we're going to come in and you just say MP and random like that. And we want random integers. And we specifically want values. The random values are going to be between 0 and 50. And I want to have, now I define my matrix. It's going to have 4 rows and 3 columns like that. And we can go like this, and you can see generated totally random values right like that. And each time you update it, it's going to continue doing so. All right, and I'll show you later how to generate random values and know that they will always be random using something called a seed. Another thing that's kind of useful is sometimes you want to be able to generate values, random value, well, they're not random. You want to generate a certain number of values between 2 different numbers. How do you do that? Well, you just come in here like this, and numpy and linear space like that. And let's say we want 1 through 10, and we want 10 values to be generated for those. And we can do it, and you can see what those are right there. And you can see also that they change if you change the starting value. It's going to get equally distanced values between those different points. Now, something else that is extremely useful is to being able to reshape arrays. So I'm going to create a new array here, and it is going to be an array that is going to have 12 random values. So I'm just going to go in and say random, and can you remember a random int like that? And I'm going to say 0 through 50 and 12 random values, exactly like that. And we can output it and see that, yes, indeed, they are random. All right, so we have this guy generated, and it's just a simple array. Let's say we would want to reshape it into a 3-row, 4-column array. Now, there are 12 values right here. And what is 3 times 4? 12. So that gives you a hint of how you will have to recreate these, because if you said I want to reshape it into a 3-row, 5-column array, it isn't going to work. All right, so make sure you understand that. So what can we do? Let's just say, just keep this matrix C6. I'm breaking a rule that I told you previously. All right, so I want to reshape it, and I want to reshape it into 3 rows and 4 columns. And just like that, I was able to do this. Let's say that I would now want to reshape into a 3D array. with 3 blocks. That is the Z value, or however you want to refer to it. Some people refer to it as sheets. It's a 3-dimensional array. That's what it is. All right, so we want to go and reshape it into a 3D array with 3 blocks, 2 rows, and 2 columns. Well, let's go and give it a different name. So I'm going to say matrix 7 is equal to, and matrix 6, and reshape. If I can spell reshape right, reshape like that. And I said I want 3 blocks. That's what that 3 is. And then I want 2 rows and 2 columns. And there it is. And matrix 7. And you can see how that is structured whenever you create that. All right. Now what I'm going to do is I'm going to reshape into a 3D array with 2 blocks, 3 rows, and 2 columns, just to show you how things look a little bit different. So I'm just going to go and copy this just to save me time and you time, and everybody will be happy. All right, so throw this inside of here, keep that like that, and I'm going to change this into, what did I say, 2 blocks, and I want 3 rows like that, and 3. And again, 2 times 3 times 2 equals 12. So that all works out wonderfully, and we can run it, and you can see that's exactly what we did. But how do you get these values out of here? Well, quite simply, if I have matrix 8, and let's keep this on here so you can see it, what I'm going to do is, let's say I want to get the second block. Well, these are 0 index, so the first block here has an index of 0. This one has an index of 1. Yes, I know it's weird, but that's the way it is. And if you're used to programming, you probably are well aware. So I want the second one, so I'm going to put a 1 inside of there. Then what do I want? I want the third row, so that's going to be 2. And then I want the first column, and that is going to be 1, or no, it's going to be 0. There we are. And there you can see we got a value of 1. What is it? I said second block, that's this guy right here. I said what? Third row. Well, that's this guy right here. And then I said first column. That is 1, and that's how I got it. Another thing you're probably going to want to do is filter arrays. So what I'm going to do here is I am going to print out matrix 6 just so you can see how things change here. And what I want to specifically do is I want to provide a Boolean array where all the values are above 20. How do I do that? Well, I can just say matrix 6 and greater than 20. Exactly like that. And you can see here, true value. Why? Because that's 49, there's 49, there's 28. They're all true. This one should not be true, and it isn't. It's false, all right? So why is that useful? Well, I can go and get a gigantic matrix, and I can return an array with just values that meet a specific condition. So I could do something like matrix 6 and matrix 6 and greater than 20. Exactly like that, and get rid of that period though, and boom. And then we'll give you just those values, and you can put any condition inside of here, and it will filter out just what you're looking for. Now, there are countless numbers of different statistic operations. This tutorial is a little bit more focused on finance above all else, but obviously it's going to be used in multiple other different areas of data science. So what I want to do here is I want to generate 50 random values between 0 and 100 and just give you a small sampling of the type of statistical operations built into NumPy. So I'm going to say random int like this, 0 to 100, and let's say 50. There we are. You can see if you want to see what it looks like. There it is, gigantic. Okay. So what I want to do now is I want to, let's say I have all these randomly generated values and I want to find the mean for them. How can I do that? Well, I can just say matrix 5 and mean value like that. And let's just do a whole bunch of them so you can see them all at one time. So let's go copy that. And I'll show you like 5 of them that you're going to use a lot. All right, so we have standard deviation like that. And this guy over here is just going to be STD like that. And we're also going to be able to find variance. And I'm not going to get into the specifics of what everything is. Standard deviation is just like the difference between all the different values, okay? And variance is a version of that. I have other tutorials that cover all this stuff in massive detail. Look in the description. You'll see a data science list of everything. And this statistics tutorial and so forth and so on, all right? All right, so minimum and min, like that. I wish I could put all those different things inside of here. But, you know, this would be forever. And the whole point of this video is to cover as much as humanly possible, as quickly as humanly possible. And you can see right there all of the different values. And if we run it again, you're going to see that those values change. All right, so great. And I mentioned before, sometimes it's very useful to be able to generate random values and replicate that randomization. So one way you can do that is you can define what is called a seed. And it doesn't matter what this value is. You can throw 500 in there. You can throw 10,000 in there, whatever you'd like. And you'll just know that whenever you use this, that it is going to give you the same random values every single time you run it. So just to prove this to you, let's go 50 and 10 like that. And matrix C9 like that. And if I come back up inside of here, run it again, you're seeing you get the same values. But worry not, in the next time you go and generate a random array, it will be random once again. So random int 0 and 50 and 10 like that, and matrix C10 like that. And there you can see if we run this again, all of a sudden magically you got random values, and these ones are still the same. All right, so there you go. That is a quick rundown of a lot of the most commonly used things you need to completely understand when it comes to NumPy. And now I'm going to do the same for Pandas. Now basically, Pandas is going to enhance NumPy, and it does so by providing numerous different tools to work with tabular data, like you'd find in spreadsheets or databases or CSV files, Excel files, all that. And it's widely used for data preparation, cleaning, as well as analysis. And it can work with a wide variety of different types of data. And it has multiple different visualization options, but I'm also going to show you Plotly, which I think is the best when it comes to visualization. Okay. So we are going to read data from a CSV file, Excel file, multiple different types of files. So you can create different functions inside of here. So I'm going to go like this. So I'm going to say get data frame. That is like the special type of array that we have inside of Pandas, just to keep everything as simple as humanly possible. And let's say I have stock information and I want to read it. Now, anytime you're reading data from a file or from the internet or from wherever, there's the potential that you could get some type of an error. So that's why I'm putting this inside of a try block. So up here, I have path. It's a path to all of my stock information. If you don't have anything in separate folders, you do not need to do this, but I'm just showing you so that you know. All right, otherwise you would just put whatever your file name is if it's in the same directory as this code that is executing. So, and I have everything set up here. So I have the path and ticker, and then that is then followed with a, it's funny, I just forgot where the plus sign is. Okay, so I got it. And CSV, all right, and make sure you put a dot here. Now, if you don't have this in a separate directory, you would just put whatever your ticker is if it's in the same directory. But I don't have that. It's in a separate directory, so I'm showing you how that works. Now, if, let's say, you have a certain column in your data that you would like labeled as the index, well, that is very commonly done with dates. So you do index column like this is equal to and date like that. And then you can say parse dates is equal to true. And that will go and automatically assign date from being a simple column to being an index you can use to search with. Okay, anytime you have a try block, you have to have some type of exception handling. Chances are it's going to be file not found error. So I'm going to throw that inside of there. And I'm just going to throw pass inside of here, which means it's going to do nothing. But you could do something like print file doesn't exist or something like that. All right, so else. And if we have no problem, we're going to return our data frame. Now, what's useful about this is we could come in and say something like Microsoft data frame is equal to, and then we can call get data frame from CSV and plug this right here. And we could go and throw inside of here Microsoft's ticker like that. And if we want to see what we get back, you just go like this, and Oh, is not defined. Oh, let's just go up here and run all. So run all. And guess what? I put the wrong path in. My path. It doesn't matter what the path is. I just want to show you, though. This is where I have my path. Okay? So I had it pointing at the wrong place, and that's why I couldn't find the file. But here you can see it found Microsoft, and it has adjusted close as well as daily return data, as well as all the dates. And whenever you see the date down there, it means it's the index, and these are just separate columns. All right. So how do we read data from Excel? Well, I'm going to define another function, and I'm going to call this get df from Excel. Doesn't matter what I call it. And I'm going to pass in whatever the file path is to grab that file. Grab this, drop that right there. df is equal to, and then what you do is you go pd and read Excel like that and pass in the location of your file. And we're just going to copy all of this stuff up here because it is exactly the same. So go up here, go over there, paste that inside of there, and there we are. Looks good. Okay, so I want to get that information from an Excel file. And I have this guy right here. I'm just going to define the file. And it can be any Excel file, doesn't matter what it is. And let's say that I just go, this is stock sectors. So I'm just going to go sectors like that is what's located inside of here. Obviously, that's what it says. And then I'm just going to say get df from Excel, copy, throw this right there. And then I am going to put the file inside of there like that. And then I can say S and sectors like this. And it's going to automatically go in, grab that Excel file, and create a data frame for it. So very, very useful. We're also going to be able to read data from HTML. So what I want to do here is I'm going to jump to a Wikipedia page. And what's really awesome is, let's say I want to get a list of all United States governors in this table. Is that complicated? Actually, it is not. I just plug in whatever the HTML location is, and then I can go and run it and get all of this information. But you said, I want this. I do not want all this other stuff that's inside of here. How do I do that? Well, I can come in there and drop down here, and I can go and just simply say, well, this is the first table, and I want the second table. 0 index, just like before. So I just come down here and I put brackets and 1 like that. Boom. Now I have a data frame with exactly the information that I am looking for. All right, and there is all of it. And I'll show you how to go in and manipulate all this information also. So that'll be really useful. Now what I want to do is show you how to get demographics data. Okay, so there are tons of different tables inside of here. And I'm trying to specifically get this vital statistics, which is lives and births and deaths and so forth and so on. So one thing that I can do is I can actually come in here and search for a word that is in the table, which is really awesome, and it allows me to go and get more information. So what can I do? Well, I can come in here, and just like we did before, I'm going to be able to say, let's go d and data is equal to, and we're going to say pd and read HTML, and just throw in the location. And then after that, I can come in and say match equal to, and the word that I'm looking for in the table is average population. And it's going to give me only tables that have that. So let's see if I got a match with just that. Okay, no, I got multiple different tables. But if I look through here and I look for the different information that I'm specifically looking for, which is actually this, okay? So it's actually, I just want the first table. So I just go like that, boom, and now I have all of the information. But it's very, very dirtied up and a mess. Don't worry, I'm going to show you how to fix things like this and things like this and all of these other different problems. First thing I want to do is I want to replace the spaces in the column names. When there's spaces in the column names, it makes it hard to work with that data. So let's go and get rid of those spaces. I'm going to go D and data and columns like this, if I can spell columns right, columns like that is equal to, and what I can quite simply do is just go X and replace, and any spaces that are inside of there with underscores, right like that. And if I want to cycle through every single column name, I just say 4x in data or D data is what I called it. D data like that, and columns. And that will give me all of those. And then I can say D data like this. And you can see magically now there's underscores everywhere there was a space. What else do I want to do? Well, I want to remove characters in the columns. So I want to remove these guys right here, and I want to remove these guys right here. How do I do that? Well, I'm going to use regular expressions to do that. So if I want to remove parentheses and everything that's inside of them, how do I do it? So I can say D data dot columns like this is equal to D and data dot columns like this, and call string dot replace, and then this is a regular expression. And what it is quite simply saying is that I want to remove parentheses. And whenever you work with parentheses, you have to put a backslash because you just need to, because it gets confused. All right, so this right here is really just this. So it's saying search for this parenthesis and that parenthesis, remove those, and then remove any letters that reside inside of there. How you do that is you go dot and star, and that means remove all. Okay, so anytime it finds all those, I want to instead replace it with absolutely nothing. So let's come in and D data. Don't know why that popped over there. Let's just drag it over here and boom. Whoops. Let's see if I can figure out what I did wrong here. Oh, I knew. I need to go and put in another one of these. Oh, I know what I need to do. Get rid of that, and I need to put quotes here to close off that. All right, is that it? Yes. All right, so I got rid of the parentheses. Now I want to get rid of these nasty brackets. So I can just go copy this and basically do exactly the different thing, or the same exact thing. So I'm just going to copy this, put this up here. And in this situation, I just replace the brackets. So it gets rid of the brackets and everything inside of it. I want to get rid of that though, and I want to get rid of that also. Run it, and now we got rid of the brackets, and now we have data that is very easy to work with. All right, what else do we have problem-wise? Well, we have this called unnamed, and it's actually year, and then we have all this garbage stuff that we want to get rid of down here. So how do we rename columns? Well, I'm just going to simply get the column that I do not like. I'm going to go D data like that, and I'm going to say rename. And you could add additional column names between the curly brackets that you're going to see here in a second. So I'm going to say columns like this, and the columns that I want to rename are, this is called unnamed this thing. So I'm just going to grab it, copy that, drag it up here, and drop it inside of there. And I'm going to say that I want that to be renamed to year, like that. Quite simple. D data, boom, and now it is year instead of nothing. All right, what else do I want to do? Well, I want to remove these characters here that are in the columns, also junking up my data. How I can remove those is basically the way that I remove this stuff up here. So I'm just going to copy that. Let's go copy that, come down here and right here, drop that right inside of there. And I am going to, in this situation, go year. You can reference your column data by its name. So there is year and D data. And again, it's not going to be columns. It's going to be year like that. And what do I want to replace? So I want to replace the brackets with anything inside of them with nothing. All right. And run it. And now you can see all that extra junk is gone. So good stuff. All right. So what would we like to do now? Well, let's say that we want to select columns. Let's find out how many children were born in a year, so, or on these years. Okay, so I can say D and data like that, and just live underscore births, the column name, and it's going to give me all of those right there. So that's very useful. Another thing I can do, let's say that I would like to get the deaths. Well, I can go and get column information in another way. I can go D data like this and deaths like that, and it's going to give me that. All right. Well, one thing I'd like to do here is it's kind of not useful to not have the year next to this, so I would like to make the year column actually the index. D data like that, set underscore index like that, whoops, like that, and I target year, and I say that in place forces this to be done to the data frame. And D and data, boom. And, oh yeah, D data set. And I want this to be dot set index. And there you can see now the year is the index and it's down here and that proves it. All right, good stuff. What else would I like to do? Well, I'd like to be able to grab data from multiple different columns and display it. No problem. Just D and data. And then you're going to put multiple different brackets here. And you're going to say live births. And we can also go deaths like that. Whoops, if I can spell deaths right. Deaths. There we go. And whoops, forgot to put the comments out of there, or the, there we are. Okay, so live births and deaths. There we go. We got all of that awesome information. Let's say we would like to grab a row of data. How do we do that? Well, we can just simply say ddata dot location and use our index. And so let's say we want 2020 and we got it. And that's going to give us all the data just specifically to 2020. All right, wonderful year. Thought I would revisit it. We're also going to be able to, I don't know, whenever you saw up here before, it says there's 86 rows. Let's say I would like to get 2020 using the row number. How can I do that? Well, I can just go D and data like this, and I location, index location. And since there's 86 of them, that means it's going to be an 85. And sure enough, you can see that we got the same piece of information. Now what I want to do is I wanted to add a column to this data. And what I would like to do is create a column that shows population growth for each year. So I'm going to say D data like that. And I'm just going to create a new column. How do I do it? Well, population growth. And I'm going to put an underscore under there like that. And then I quite simply just say D and data like that. And I'm going to get the live births. And I'm going to subtract from it the deaths. All right, so D data like that and deaths like this. And there we are. And if I say D data like that, we now have a new column. It's called population growth. And you can see how all of that is working out here. And you can also see the population growth is actually falling. And it was particularly bad in 2020, obviously. Okay, so what else would we like to do? Well, we want to delete a column. That's also something that's pretty useful. Let's say that we found population growth to be quite depressing, and we decided that no, we do not want that in our table. You just say drop it, and you put population growth, which is the name of it, and then you have to go axis is equal to 1 to get rid of all this information, and in place forces it to affect our data frame. And the data, if you run it again, now you see that it is no longer on our list. So also good. How do we delete a row? Well, let's say that we do not like the year 1935 and we want it to not exist anymore. Well, we just say drop and 1935, exactly like that. And the difference is you are going to use a different axes here. And other than that, everything else is the same because we're dealing with rows. So I think I do it that right there. Yes, this is going to be axes 0 in place true and the and data. Boom. And there you go. And 1935 no longer exists. Sorry, 1935. Another thing we want to do. We often want to manipulate data. Let's go and get some new data. And what I'm going to do is I'm going to specifically get list of countries by GDP. And it's the second table. You're well aware of how this works because you have done it in the past or you've seen me do it. All right, I'm going to show you some new ways of working with this data so you're completely aware of how to clean up your data. One of the #1 skills you must have. All right, so what I want to do here is, let's say that I want to, we have a multi column name list here. We don't want that. We want to get rid of this altogether. All right, so let's come down here. First off, let's go and see what those column names are. If you want to print out your column names, you can just say for something like column in, and what did I call this? I called this C data. All right, in C data like that, and columns like that. And then I can just say print and column. Okay, so you can see that we have these multi-columns and we don't really particularly like them. So I want to delete one of these, the top part of the multi-level column name. How do we do this? Well, we can just say C and data dot columns like that equal to C and data and columns like this and drop level. And there we are. And C data. And you can see that we got rid of that. All right, so that's useful. What else would we like to do? Well, we only want to keep columns if they haven't been used, the name hasn't been used prior. So let's say we want to keep country, region, estimate, and year, but we do not want these other estimates and years. These are from different data sources. Let's say we only trust this, and we want to get rid of any other duplicates that lie inside of there. How do we do that? Well, C and data is equal to C and data and location, like that, dot location. And this colon means we want to start from the beginning to the end. And what this is going to do is it's going to keep column names if they haven't been used, if the name hasn't been used prior. All right, so we'll go like this, and C and data dot columns, like that, and duplicated, like that. So there we are, and C and data, and whoops, put location in here 2 times. All right, get rid of that, like that. And there you can see we got rid of the duplicate row or duplicate columns. This stuff happens all the time. So I'm just showing you all the different ways of messing with this data. What else would we like to do with our data? Well, we have nan values down here. We want to get rid of any rows that have nan values. So I'm going to say C and data is equal to C and data and C and data, like that. And I am going to get rid of, here you can see estimate and year inside of there. So I'm going to go C data and I will say estimate if estimate is a, whoops, this has to have an opening bracket like that. All right, estimate and not NA. So we'll just draw and put a little quote inside of there and not NA. All right, and then close off this bracket and C and data. And there you can see we got rid of those, any row that had a nan value inside of it. All right, what other problems do we have here that we would like to clean up? Well, I would like to remove these, any brackets that are inside of here. See these brackets with that extra junk that's inside of there? So what am I going to do? I'm actually going to come up here and I'm going to use what we used previously. And where is it? There it is. All right, so we'll just grab this guy right here, scroll down, paste it inside of there. And then we just have to change a couple different things here. Well, actually, very, very little. So this is going to be C data, of course. And this is going to be C data and C data. It's also called year, right? Uppercase year. Yep. So that works out good. And do I need to change anything? No. I think that's all I need to change. And there you go. We got rid of that extra junk that was in the year. What else would we like to get rid of? Well, I would like to change this from being country territory to just country. So let's, I don't know if that's necessarily the best thing to do, but I'm just doing it because I'm just trying to show you different things. So here I am going to, and also I'd like to change estimate into GDP just to show you how to change multiple different column names. So you just say rename and columns equal to, and it is country and territory. I'm just going to copy this right here. Copy and paste that down there. And I want to change it to just simply country. So country like that. And then you put a comma and then you can put in more. Estimate, I want to change that to GDP. So GDP like this. And C and data, and you can see that it did not work. Oh, and the reason it did not work is I need to go like this, and in place is equal to true. And now it did work. All right, good. So now you got an example of that. Another thing I'd like to do, I'd like to remove these stars that are next to these country names. So let's do that as well. C and data, and that is in the country column. And C and data and country like this.
And I'm going to say string and replace, and I will get rid of the star and replace it with nothing. And like this, and see, and data, and boom, those are all gone. Now, something else that's really awesome is, let's say that I would like to find out the mean GDP by region. Okay? Well, what you do is you use something called group by. So I'm going to say see data like this, and group by like that, and we are specifically looking for region. So region like that, and dot and mean like there, and boom. And you can see just quite simply we can go and get the mean GDP by region for all these different countries. And you can also go and get the median also. So I'll just copy this, and standard deviation, you can do all this stuff. But we'll do the median like that, and boom. And you can get that information as well. Let me now give you yet another example before I start covering Plotly. So let's say we want to do some analysis here. And we have two stores, and they sell different types of ice cream. And they sell a certain different number of ice creams. Well, what I want to do is I'm going to structure this as a dictionary, and I'm going to define my store here. So I'll have store, and this is just a type of somewhat of a real world example. Okay, so let's say that we have different amounts of ice cream sales. We have different flavors, and those flavors specifically are going to be chocolate, and I'm just going to abbreviate this, vanilla, and vanilla, and strawberry, and let's say chip. All right, for chocolate chip. Okay, so we have all of that information, and also we have sales information. So sales like this, and I would like to, okay, so we sold 26 and 12 and 18 and 22. All right, so that is how all of that data for those ice cream stores is going to work out. Well, let's say I want to convert this dictionary into a data frame. I say IC data is equal to PD dot data frame like that, and pass in my dictionary. And I can say ice cream data, and there you can see. So we have store 1 sold 26 chocolates, and store 2 sold 12 vanillas, and all of this. Let's change this to chocolate just to change things up here a little bit. So, chocolate. So chocolate like this, and there you can see. All right, so this store sold vanilla and this sold strawberry, and they sold an equal amount of, or a different amount of chocolate, but they did sell chocolate ice cream. Okay, so what I want to do here is I want to group my data by store number. So I'm going to say by store equal to, and I can say ice cream data like that, and I want to group by and the store. All right, and I can then go and get the mean sales by store. So I can say by store and mean like this, and you can see how that works out. So we sold 22 and 17 in between these different stores, mean-wise, okay? And let's say that we would also like to come in and get the sales total just for one store. Well, after we go and have it organized by store, well, we can come in and we can say sum like that, and the specific location for is going to be 1 like this, and we can run that. And we can see that one store sold, which is actually this one, sold 44 different chocolates. All right, and that is store 1. See, store 1, and this would be store 2. You can change that to 2, and you can see the difference between them. Okay, and also what's really cool is you can use multiple different functions to get a whole bunch of data on this information that we just input. So we can say by store, and just simply by saying describe like that, boom, we're going to be able to see standard deviation, mean, and counts, and so forth and so on. All right, so there you go. That is a rundown of the different things you absolutely must know about Pandas. And up next, I'm going to talk about Plotly. All right, so I absolutely love Plotly. It's my favorite library for plotting data. It's just what I use. And basically, Plotly is going to allow you to create about 40 some really beautiful interactive web-based visualizations that can also be displayed inside of Jupyter Notebooks or saved to HTML files. And it's widely used to plot scientific, statistical, and financial data. And in the description for this NumPy, Pandas, Plotly, inside of the description on GitHub, you'll find the installation instructions. Very easy. You just copy and paste two things, paste them in. All right. So these are the libraries we need to import. Not going to go waste your time going over that. I'm going to go in and actually show you some stuff. So what I want to do here is I just want to do some simple line plots. They're going to get progressively more complex, and then I'll show you a couple other different plots as well. And this is going to have kind of a finance leaning because that's really what I'm into right now. Okay, so what I want to do is I want to plot the value of $1 invested over time. And I'm going to do it for one stock, and then I'm going to show you how to do it for two stocks. So I'm going to create something called data frame stocks is equal to px dot data and stocks. So I'm going to use some built-in Google pricing data here, and this is where I'm going to get it from. All right, this is where I'm importing this information. So I'm going to go px dot line like that, and df and stocks is where I'm pulling this from, and I want the date. That is how it is stored. I'm going to show you how to work with CSV files and such later on. I'm specifically looking for Google, and I am going to label some things. I'm going to say labels is equal to, and on the x-axis, the label on this plot is going to be date, like that. And for the y-axis, don't worry, it's going to get much more complicated as we continue. I'm going to do value of dollar, over time, okay? And we can go like that. And you can see if we invest $1 in 2018, that out here, that in the end of 2019, it is now going to be worth $1.21. All right, so pretty cool, nice growth of your money. All right, so let's say I would want to instead go and plot multiple different plots. How hard is that to do? It's actually extremely easy. Let's just copy this. Let's paste this inside of here. And y this time is going to be two values. So I'm going to have Google, and you can see the difference between investing in Google and Apple over this time period. So I'll go Google and AAPL. There's Apple, and that's it. And if we would want to throw a title on this as well, we can just come in here like this, and we can say title is equal to Apple versus Google. And we will see which is better. And you can see there indeed that Apple, and you can also see it printed out this little key. And if you invested in Apple, instead you'd have $1.67. All right, so very simple line plot. Let's get more complicated. Let's say you would want to put multiple different plots on here, and what I also want to do is I want to show you some different line styles. So I'm just going to do some random values. I'll have x1 is equal to, and I want to use linear space to define values from 0 to 1, and I want to have 100 of these. So there we are, and space like that, 0 and 1 and 100. And I am going to also then generate a whole bunch of random y's. So I'm going to go y0 is equal to, and np dot random and random n 100. And so they stack on top of each other. I'm going to have this be 5 above, and then the other random y values I'm going to stack differently. So I can say, let's just change this to negative, And let's change this. Is that a 0? I hope so. Now it is. Okay, and change this to 1 and make this -5 like that, and paste this here, and we'll print like 3 of them on the board, or yeah, 3 of them on the board, and then let's just get rid of this for that, and go and get rid of that. And now what we're going to do is, after we have our values, we're going to plot them. How you do that is you define your figure object by going go and figure like that. And then what I want to do is I want to add multiple different lines using different styles onto the same figure. To do that, you go figure and add trace and go dot scatter like that. And we're going to be using the same x value for all of these. So x is equal to r underscore x and 1. And then y is equal to r underscore y and 0. And let's go and change the style of the line. You do that. Here I'm just going to do a simple line. And you just say lines like that. And then if you also want to define a name for it, you go name is equal to, and I'm just going to call this random 1. And I'm going to create the 1 for each one of these. So paste and paste like that. And that stays the same. This is going to be 1, and this is going to be 2. And we could also do little dots, which we call markers, like that. Or we could just quite simply just say markers, like that. And change this to random 2 and this to random 3. And it's going to plot all those out on the screen at the same time. And you can see exactly how those look. All right, so just some different styling that is provided, kind of neat stuff. Now what I want to do is I want to add even more detail to my plots. So what I want to do is I'm going to do a plot of Apple stock data. And I'm going to go and grab it. I know it's here, so I don't need to do any type of exception handling. PD dot and read, famous last words, I know. CSV file, and it's called AAPL.csv. All right, so we got that. And I'm going to define my axes for the plot I'm going to make, AAPL. And I specifically want the date information. And what I'm going to do here is have sliders and so forth, a whole bunch of other different things. Y is going to be AAPL and underscore DF. And I want adjusted close for that. All right, so I got that set up. If you want to know what AAPL, the data frame itself, looks like, there it is. Okay, so there's the data frame that I'm going to be pulling information from. And if I want to now draw this, I have to go figure again and create my figure that I'm going to add my values to. And I'm going to say figure dot add trace like that, and go dot, and I'm going to do a scatter plot like that. X is equal to X and Y is equal to Y like that. And figure dot, if I want to come in here and let's say I want to add a slider and I also want to change the title on the x-axis, I go figure update and underscore x-axis like that. And I can define all kinds of different things. I'm just giving you a rough estimate here. So I'm going to say, whoops, didn't want to do that. If I want to show a slider on side of it, which is going to really look awesome, I can say range slider and visible is equal to true, like that. And if I want to go and give it a title, I can say title is equal to, and I can say something like, give directions like zoom on dates using slider, like that. And then I can say figure, and I also want to add a title to the y-axis. So figure update y-axis, like that. And title is equal to stock price, and this is going to be in dollars. And I need to put this inside of quotes, however. So let's just select that and go like that. And there you go, and run it. And now you're going to see that information. So let's go. Oops, did I accidentally hit it too many times? Yes, I did. Let's go click it again. There we are. All right, so this is going to print out all of Apple's stock data. And there's a neat little slider down here. So let's say I wanted to come into a very specific amount of time and analyze that. I'm going to show you other different ways to chart. And you can see that I can zoom in on any of these specific parts, and I can go to any specific date, and it's going to give me the time for, or the price for Apple stock. All right, so awesome. Let's get more details. What I'm going to do, I'm going to go really crazy this time. Okay, so what I want to do, I'm going to copy part of this up here. So I'm going to copy this part right here and adjusted close, and let's get this and go figure. And I'm also going to go and get this guy right here. So add trace, so copy, and just to mix it up, I'm going to use Microsoft now as an example. So I'll say change this to Microsoft and Microsoft up here. So Microsoft and date and adjusted close, both the same. Change this to Microsoft like that. That's the same. And the scatter plot is also going to be the same. Okay, so we run it, and now you can see here is Microsoft data. Now, one thing that is really cool is I can go and add in a range slider, but I can also go in and provide buttons that allow me to click on the buttons and jump to different ranges, which is so useful. And this is what it looks like. All right, so what you do is you go and you do update, layout, and x-axis dictionary, and you can do range selector. And then inside of here, you have a dictionary of buttons, and you can label them, and you can have, let's say, one of the buttons when it's clicked on is going to use steps of days and 10 steps of days. And what this is going to do, this is just simply a label, and this is going to show you the last 10 days of the stock. And here, let's say we want to work with months. We want 1 month, and we want to display 1 month. That's what that means. 6 months, 6 months, month. 1, year to date, and year. We want to show 1 year. We can change this to 2 years. We can change it to 5 years. We can do whatever we would like. All right. And if you want to show all the stock data, you just put all inside of there. And here I'm just saying that, yes, I want to show the range slider and date. Okay. And also I have the title. I added the y-axis. And now what you can do, you have your slider, but you can also just simply go 1 year of data and year to date worth of data, 6 months of data, 1 month of data. All right. 10 days of data. All right. And you can just click on these simple buttons and get very, very specific information. So it's very useful. And now what I want to do is talk to you about candlestick plots. All right. Very, very useful. So basically, I'm going to abbreviate this. Candlestick charts are useful because what they do is they show the open, the close, and also they show the high and the low, all in one place. So what I want to do is I want to work with Apple stock. So I'm going to go X is equal to, well, let's first show you AAPL like that. And it's AAPL data frame. Yeah, there it is. Okay, we obviously need this data. So you need the low, the high, the open, the close to be able to do this with candlestick charts. Okay, so and what basically a candlestick chart can help you sort of sense the emotion involved around a stock in the near term. So that is why they are found to be very useful. So, and I'll get more into that as I get more into technical analysis and so forth. All right, so I'm going to have the x-axis be date. I need to define my close, and that is AAPL, and that's going to be adjusted close like that. Whoops, and close is equal to. And I also need to get the high, which is going to be equal to, why don't I just copy this right here and paste that inside of there. And you can see, of course, that that has the column name of high. And let's go and do the low, which is equal to, there we are. And we can just type in low like that. And if we want to get our open, let's just call this open price equal to, and paste that inside of there and change this to open like that. And now that we have all of those set, we can go figure is equal to and go and figure like that. And then we can go figure dot add trace like that, go dot candlestick like that, and then just go x is equal to x, and high is equal to high, and low is equal to low, and open is equal to open P, and close is equal to close. All right, like this. All right. And name Apple is not defined. Where did I do that at? Oh, Apple. I should have put DF. So DF and DF and DF and DF. And there we are, and run it. And there you can see is our candlestick chart. All right. But it's not very useful because there's so much data, and but I can use my little scroller to come in here and scroll through this data. All right, and I'll get more into why candlestick charts are awesome later. All right, so what I'd like to do is update my layout with our buttons. And what's awesome with Plotly is everything's the same. So I can just go up here, and I can say update layout, copy, come down here, and paste it inside of there, and it will automatically work. And boom, and now I have the ability to go and do all of this extra information. All right, some of those aren't going to work though because I have a limited amount of information, which is basically just 2020. All right, what else do we want? Well, let's say that we also would like to come in and we would like to add different titles. So I can say figure and update and layout and x-axis and title, and I want to say dates. Whoops, hit the wrong button. Dates like this, and I want the y-axis title to be equal to stock price. Whoops, stock price, and also whoops, keep forgetting to put the quotes inside of there. There we go, and I bet you I forgot it there also. Yes, I did. All right, stock price, and then let's say we want a title for our whole entire chart. We go title is equal to and Apple candlestick chart. Okay, and there we are. So there we go. Added even more capabilities to it. What else would I like to do? Well, let's say that I would like to really target in here the whole pandemic period and where the stock sort of tanked because of that. And it's basically in this area right here before it started to go back up again. All right, we can go and put annotations on this. So we can say figure dot and update layout like that, annotations is equal to, and we go dictionary, and we're going to say where we want to place the annotation. So that is going to be X, and we're going to say that we want to place it on the date of approximately, this is approximately when the stock market started reacting to the pandemic. And I'm going to say that I want this to be around the price of $85 on the y-axis. That's where it's going to point at. So y is equal to 85. And I want the text to read pandemic affects market, to sort of point that out in the chart. And then I'm going to put my X anchor for this on the right. So right like this, and run it, and you can see right here is a little annotation that points at where that affects it. Now, let's say that I would like to put like a line underneath here that shows the entire time in which the pandemic negatively affected the stock market. I could say figure dot update and layout, and I can say shapes is equal to and dictionary, and I can just plug in dates. So I'll say that I want this line to go from this period of time right here. So copy and paste that right there, and I want it to go through the, let's just throw this inside of here, And let's say that the stock market negatively affected was affected negatively by the pandemic through this period of time. All right. And I will then go and say, just define y as being equal to 1, which is basically just going to define the size of it. So like this, and y is equal to 1. All right, 1 like that, and run it. And now we should have, yes we do, we have a line that goes right down here that sort of defines that area. And it's just showing a demonstration, not the greatest thing. You know what would look really nice? If I went and covered that entire area with an low opacity rectangle. And I'm going to do that. So I'm going to say figure dot, and you can go add. It's so awesome what you can do with Plotly. This is and as my tutorial continues here, where I cover technical analysis and so forth, I'm going to get into more awesome things you can do with Plotly. This is just the tip of the iceberg. So equal to, and again, we're going to do the same thing. So I might as well just copy this. So I'm going to copy that, and I'm also going to copy this. So copy and just paste this inside of here. And whoops, and this needs to be x 0 is equal to like that. And then what I can do is I'm going to say that I want my fill color to be something like light salmon, and I want it to be lower the opacity so you can see the chart through it. So I'm going to say opacity is equal to 0.5, and which is 50%, and then I'm going to say layer is going to be equal to below, and I'm going to say that I do not want a line width for this rectangle that I'm defining. And if we run it, you can see that we went and created that as well. All right, so all of this stuff, and I'll be getting more into it with technical analysis and so forth. And on top of that, I provided some other bonus stuff here. Well, you know what I'm going to cover? I'm going to cover open, high, low, and close as well. Why not? Okay, so while candlestick charts have a rectangle that is, let's go and zoom in here so you can sort of see, the rectangle that is going to represent the high, low, and the close. And you can see all of that data right here with the wicks. That's the little lines that are coming out of the top and the bottom. Sometimes they're referred to as shadows. A open, high, low, close chart is going to use ticks to the left and the right. Here, let me just show you. All right, so basically, we can just say figure dot, and let's just copy that. Why not? It's just no point. Might as well. It's almost exactly the same. So let's come in and go figure, grab this guy right here, and copy it. All right, so copy this guy and come down inside of here, paste this inside of there, and everything else is the same. Add trace, and the thing we do different is we say OHLC, and we have the high, low, blah, 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 blah. All right, everything's the same. And there you go. And there we have our little chart. I'm going to click on this so that I can see the whole thing. And there it is. And if I zoom in, you can see these a little bit better. All right, so zoom in like that and maybe try to find one that's pretty big. There we go. That one's kind of big. So let's zoom in and zoom back over here and zoom back over here. All right, so what you can see here is you're going to have your opening price on the left. The bar represents up here, represents the high, here the low, and this the closing price. And once again, it provides you with the option of seeing momentum depending upon the length of the line. Very, very useful to use. And one more thing I'm going to do, I'm going to show you how to do multiple plots by merging these different types of plots that we just covered here. So what am I going to do? Well, why don't I just leave this here? I'm going to just add to this what I have here already. Okay, so I have the OHLC chart, and then I'm going to say A_X is equal to AAPL and data frame and the date. I'm going to put the regular chart on top of it. And A and Y is equal to AAPL and data frame. And I will have my adjusted close like this. And then I'm going to add that also. So we'll do figure add trace like this, and go dot scatter like that. X is going to be equal to AX underscore X, and Y is going to be equal to A underscore Y, and I'm going to have this be a line. So and I'm going to put some different attributes inside of here. So dictionary, and let's say that I want the color of the line to be blue, and I want, whoops, like this, color equals blue, and I want the width of the line to be equal to 1.5, and I want it to be dashed, dots, so that it's a little bit easier to see. And dash is equal to dot, like that. I think I got everything right. Let's run it. And now you can see that it has both of those pieces of information. Looks kind of cool. And we can zoom in here and look at it. So there you go, guys. Hopefully you find that useful. A rundown of the most common things you're ever going to do with NumPy, Pandas, and Plotly. More videos are coming with real-world examples. And like always, please leave your questions and comments down below. Otherwise, till next time.